EVA, Visual Analytics to Identify Fraudulent Events. In tight collaboration with domain experts, we analyze the real-world problem of financial fraud detection and iteratively design EVA, a VA approach to improve their current workflow. EVA interweaves well-known visualization techniques, which our domain experts are mostly familiar with, and automatic methods. Moreover, we present a striking insight from an evaluation with 3 target users. We propose the integration of a VA step to the current detection workflow. Our interface is composed of multiple views that are connected via brushing and linking. At the top right, the user can select one or more bank accounts for detailed investigation. Only transactions from the selected accounts are displayed in all the other views. The temporal view shows 2 connected charts. We provide an overview line chart at the bottom which shows the total amount of money transacted over time. This view makes it easy to identify high amounts of money transacted, and it's used to filter the upper bar chart, which also shows amount of money transacted, but on a temporal basis. Each day that contains at least one transaction that was automatically flagged as suspicious is highlighted in red. The score transaction view shows how the automatically generated score was composed of subscores for each transaction. Each transaction is represented by a line. The first axis shows the overall score, and the other axis shows the subscores from which the overall score was composed. Investigating the similarity of subscores of different transactions allows for the identification of similar transaction patterns, which is even more supported by interactive filtering. The scatter plot shows the relation of the 2 most important dimensions: the amount of money that was transacted and the overall score of this transaction. Transactions of high amounts of money can be found at the top of the plot, while transactions with high scores can be found at the right side of the plot. This allows for an easy identification of outliers which may indicate suspicious transactions. Another important information is who received high amounts of money from the selected account and who received most frequently from the selected account. To this end, we provide a ranking bar chart of receivers' accounts that received top amounts of money, as well as another ranking bar chart of receivers that received most frequently from the selected accounts. Interactive linking and brushing again filters the data displayed in all other views. At the top right, we see 2 pre-selected accounts. Each account is represented by a bar, and the length of the bar shows the amount of transactions done by this account. The user can select an account for detailed investigation in all other views. Finally, we provide a dynamic table for details. Transactions are represented in rows, and sorting these transactions with respect to their overall score indicated in red. Sorting transactions according to the amount transacted shows us transactions with very high amounts of money first. As we can see, some of them are flagged as suspicious, but not all of them. Next, a striking insight found by one investigator during the evaluation. He starts with filtering the suspicious period. He quickly analyzed the filtered transactions using the table. He realizes a strange peak for a transaction flagged as non-suspicious. He filters the most frequent receivers. He just discovered a false negative, a transaction at the same day to the same receiver of an even higher amount of money as the other fraudulent transactions. Here are some sentences from the target users about EVA. I like it because it is very interactive and you can browse the data, even if you don't know what you are looking for, and find new insights. Here we could see what is possible and what is available, so we can rethink what we can offer to the bank.